The 51st question is, if A, B, C are three natural numbers such that A plus B plus C is divisible by 6, then A cube plus B cube plus C cube must be divisible by, he is asking us, 6, 12 or 24 or none. Let us examine. It is an interesting question. First of all, what are A, B, C? A, B, C belong to N. Anything more? Yes, there is something. A plus B plus C is divisible by 6. Therefore, A plus B plus C is equal to 6M for some M belongs to N. Can we write like that? Why not? It is divisible by 6. He has committed it. Therefore, we can take A plus B plus C as a multiple of 6, that is 6 into something. Now, we are asked to have about the information about A cube plus B cube plus C cube. Yes, we are to use this and find A cube plus B cube plus C cube. Well, consider A cube minus A. What is A cube minus A? That is A into A square minus 1. What is it again? This is A minus 1 into A plus 1. Am I right? You can observe one particular thing here. A minus 1, A and A plus 1. How are they? They are successive integers. Here, this is the right occasion for us to recollect one of the most beautiful concepts regarding the successive integers. What is that concept? If you have a product of consecutive r integers, then it is divisible by r factorial. If you have 3 consecutive integers, the product is divisible by 3 factorial. If there are 4 consecutive integers, then the product is divisible by 4 factorial, like that. If you have n successive integers, then their product is also divisible by n factorial. A beautiful concept it is. By making use of that concept, these 3 are 3 successive integers, therefore divisible by 6. Similarly, in a similar fashion, you will be able to have B cube minus B is equal to B into B square minus 1 is equal to B minus 1 into B plus 1 divisible by 6. Same, divisible by 6. Just like that, C cube minus C into C square minus 1 is equal to C minus 1 into C plus 1. Just like in the previous cases, this is also a product of 3 consecutive integers. Definitely, this will also be divisible by 6. Therefore, this is divisible by 6. This is divisible by 6. This is also divisible by 6. What do you say? Implies A cube minus A plus B cube minus B plus C cube minus C is also divisible by 6. Is also divisible by 6. As the individual number is divisible by 6, their sum is also divisible by 6. No doubt about it. Let us now approach the required one. In this sum can again be taken as A cube plus B cube plus C cube minus of A plus B plus C. As we have got the result, this entire thing is divisible by 6. Therefore, this is equal to, I like to say, some 6k for some k belongs to n. You see, what is the fate of A plus B plus C? It is 6m. It is 6m. Minus 6m goes that side, plus 6m. So, what do you get? This is A cube plus B cube plus C cube is equal to 6k plus 6m is divisible by 6. Is divisible by 6. is divisible by 6. So what is the right option? Option A is the right option. Here in this way of answering, the crucial idea is this. How can we get that idea? We have to get a cube plus b cube plus c cube, and also we must be able to use a plus b plus c is divisible by 6. So by clubbing those two, we can frame this idea. It's not impossible. Thereby we will be getting a cube plus b cube plus c cube is surely divisible by 6. So the right option is option A, and the right option is right answer is 6. That is about the question. The next question is question number 52. What is the greatest common divisor of 31C3, 31C5, 31C6, etc., etc., 31C29? We want to have the greatest common divisor or the highest common factor, whatever you say, we like to have. The option, first option is 31, second option is 2, third option is 17, and the fourth option is none. To answer this question, the knowledge of a prime number and knowledge of the coefficient PCR where P is a prime number, where is it P is a prime number, or NCR when N is a prime number. Let us first observe some, let us choose a prime number, say 7. 7C, what is 7C3? 7 into 6 into 5 by 3 into 2 into 1. You please observe, this 7C3 is surely an integer. 7C3 is surely an integer by the property of NCR. So all the numbers must be factors of some factors in the numerator, except 7. Except 7. 7 is prime. It cannot be divided by any integer less than 7 except 1. Isn't it? Therefore, this is surely a multiple of 7. Like that 11CR, you observe 11 into 10 into 9 into etc. by R factorial. Again, all the things in the denominator will be cancelled. Of course, 11 will remain. In 11, there will be no factor in the denominator which can cancel 11. Therefore, 11CR is a multiple of 11. 13CR is a multiple of 13. NCR is a multiple of N, provided N is prime. Provided N is prime. Thinking that in view, 31C3, 31C5, 31C29, you observe all of them, they are started with a prime number. 31 is a prime number. Therefore, 31 is a factor of 31C3, 31C5, 31 etc. etc. 31C29. Isn't it? Therefore, first of all, 31 is a factor. 31C3, 31C5, 31C7, etc. etc. 31C29 is equal to 13CR 3 less than or equal to R less than or equal to 29. No doubt this is, it is 31, not 13. Therefore, 31 is a common factor. Common factor of 13CR for all 3 less than or equal to R less than or equal to 29. And it is very clear to see that there will be no more factor for them greater than 31. Why? Because if you expand 31CR, if you look at the numerator or denominator, you will be having integers less than 31 only. So 31 is a prime number. Every integer available in 31CR is less than 31. None can divide 31, and there will be no other factor at all for those which is greater than 31. Hence, the greatest common divisor is just nothing but 31. The only crucial point here to observe is 31 is prime. And by observing the coefficients 31C are 31C, 31C5, etc., etc., 31C10, whatever coefficient you like to observe, you like to test, it is a multiple of 31. There will be no other factor at all greater than 31, and it is the greatest common factor. That's all. So what is the right option? Option A is the right option, and answer 31 is the greatest common divisor. So option A is the right answer. That is the question. In this question, the number of 4-digit positive numbers are required provided the product of their digits is divisible by 3. The product of their digits is divisible by 3. How many digits are there actually? 0, 1, 2, 3, etc., 10. How many digited numbers are required? 4-digit numbers are required. Therefore, how many places are to be filled? 1, 2, 3, 4. As usual, a precautionary measure is to be taken about the first place. Why? Because it must be filled with a non-zero digit. How many non-zero digits are there available with us? 9. 1, 2, 3, 4, 5, 6, etc. 7, 8, 9. So it can be done in 9 ways. What about the remaining places? There is no restriction at all. You can use 0 also. Therefore, these 3 places can be filled in 10 ways, 10 ways, 10 ways. Altogether, the total number of numbers is 9,000. How many such numbers are there? 9,000 numbers are there. Out of those total 9,000 numbers, we are supposed to pick out the required number of natural numbers. What type of natural numbers do we require? The product of the digits must be divisible by 3. Product of the digits must be divisible by 3. And to have that, at least one of the digits must be either 0 or 3 or 6 or 9. That's it. 0, 3, 6 or 9. They must be there. Unless or otherwise, it is not possible to have the product divisible by 3. Divisible by 3. Okay. Instead of calculating all those, let us subtract those numbers in which do not contain 0, 3, 6, 9. How many such numbers will be there? This is the total number, and number of numbers without using 0, 3, 6 or 9. So, we are omitting these 4. Total number of digits is 10. You are omitting these 4. Remaining 6 digits. How many such numbers will be there? 6 places, 6 times, 6 ways, total 6 power 4. Are these 6 power 4 numbers valid or invalid? We are supposed to subtract these. This is the negation to the requirement. Therefore, total number of numbers is, that is required number of numbers, that is answer is 9,000 minus 6 power 4. But we know what 6 power 4 is. What is 6 power 4? 1296. 1296. If you subtract 1296 from 9,000, what are you going to get? You are going to get it to be 5464. This is the right answer. And it is available in the option B. Second option is the right answer. That is 5464 is the correct answer for this question. Let us switch over to the next question before us. That is question number 54. In this question, the number of ordered pairs of natural numbers of the form ordered pair m and n satisfying m less than or equal to 2n less than or equal to 60 and n less than or equal to 2m less than or equal to 60 is 240. Option B is 480. Option C is 960. Option D none. That is the question before us. By the way, what are all the conditions imposed on the nature of m and n? M belongs to set of natural numbers, n belongs to set of natural numbers with the condition that, what is the condition? M less than or equal to 2n less than or equal to 60. What is the other condition? N less than or equal to 2m less than or equal to 60. That is the condition. Let us first follow these conditions carefully. 2n less than or equal to 60 means n less than or equal to 30. I have made use of this. 2m less than or equal to 60 implies m is less than or equal to 30. N can take the values 1, 2, 3, 4 and so on up to 30. M also can take the values up to 1, 2, 3 etc. 30. So the total number of ordered pairs is total number of ordered pairs is equal to 30 into 30 is equal to 900. Why? Because both m and n belong to the set containing 1, 2, 3, 4 etc. 30, and we are supposed to find the ordered pairs, that is nothing but A cross A, where capital A is equal to 1, 2, 3, 4 etc. 30. Therefore, the total number of ordered pairs is 30 into 30, that is 900. Well, are these entirely the required ordered pairs? No. We have followed this condition only. We are not able to follow this now. M less than or equal to 2n and n less than or equal to 2m. We are now to attend to that. Well, we want to have actually m less than or equal to 2n. Let us observe its negation. Why? Because if you are able to calculate the number of ordered pairs in a negation view, we subtract these from the total. Right. So we have to find the ordered pairs with m greater than 2n or n greater than 2m. How many such ordered pairs are there? How many such ordered pairs are there? We shall calculate. You see, if you observe symmetry, number of ordered pairs like this and number of ordered pairs like that will be same. We now calculate one of them, either this or that. Let us recollect the total number of ordered pairs with a part of the given restriction was 30 into 30 is equal to 900. Out of these, we are now to collect the required number of ordered pairs. We have not followed the condition m less than or equal to 2n and n less than or equal to 2m now. We now find the ordered pairs which do not satisfy that condition. That is 2n less than m and 2m less than n. Actually speaking, you have to find both the ordered pairs. But by symmetry, if you are able to find one set of ordered pairs with 2n less than m, automatically the same number of ordered pairs will come even if you calculate for that if 2m less than n also. So we calculate one such thing first of all. That is, let us keep the condition 2n less than m in the beginning. 2n less than m in the beginning. And they can be estimated by giving some values for either m or n. Values of n I am estimating. As we could have planned to find the number of ordered pairs which do not satisfy the condition m less than or equal to 2n or n less than or equal to 3m, we have started. That is, we may have to calculate those ordered pairs with 2n less than m and 2m less than n also. By symmetry, they will be same in number. So let us first calculate those ordered pairs with 2m less than n. Well, it can be estimated by giving some values to n and m. Suppose n is either 1 or 2. either 1 or 2. If n is 1, you cannot have m with 2m less than n. 2m less than 1 means m less than half, not possible. If n is 2, 2m less than 2 means m less than 1, then also it is not possible. Number of such m's is 0. Well, next, for 3 and 4, n is 3. 2m is less than 3. How can you have? M is 1. 2 ones are 2, 2 less than 3 is possible. 2 2s are 4, 4 less than 3 is not possible. So there is only 1. For 4 also, 2m is less than 4, m is less than 2, m is 1, only 1. Next one, suppose either 5 or 6. Take n as 5. 2m is less than 5, m is less than 5 by 2. That is m is less than 2, m is 1. 6, 2m is less than 6, m is less than 3 is 1 and 2. So how many such things are there? 2 things are there. Similarly, for 7 and 8, there will be 3, etc., 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 etc. If you proceed for 29 and 30, there will be 14. There will be 14. For 1, 0. For 2, 0. For 3, 1. For 4, 1. For 7, 3. For 8, 3. Okay. What is the number of numbers with 2m less than n? Is 2 into sigma 14. That is 2 into 14 into 14 plus 5 by 2. That is 14 into 15. What is 14 into 15? 14 into 15 is 210. 15 15s minus 115. That is 210. With this condition, 2m less than n is 210. And with the condition 2n less than m, one more 210 ordered pairs will also be there. Altogether, how many invalid ordered pairs are there? 420 ordered pairs are there. So, you are supposed to delete these invalid ordered pairs from the total number of ordered pairs, that is 900. Therefore, answer is 900 minus 420 is nothing but 480. Is nothing but 480, and it is available option B. Option B is the right option, and answer is 480. That is the question. The next question before us is 55, question number 55. In this question, a square wall is tiled with congruent square tiles. All the tiles are red except those along the 2 diagonals which are blue. If the total number of blue tiles used is 121, then find the number of red tiles used. There is a big wall which is in the shape of a square. It has been tiled with congruent tiles. Square tiles, those tiles are also in the shape of square. Okay, all the tiles, those tiles are of 2 colors, red and blue. Moreover, those tiles which are placed in the diagonals are only blue. All the remaining are red. He is saying all the tiles are red except those along the 2 diagonals which are blue. And the total number of blue tiles used is 121. What is meant by that? He could have used a total of 121 blue tiles, that is along the diagonals. Along the diagonals, he could have used 121 tiles, blue tiles. And we are asked to find the number of red tiles. Let us calculate. Here the wall present is a square wall. It has been tiled with congruent square tiles. All the tiles are red except those along the 2 diagonals which are blue. Therefore, those tiles which have been arranged around the diagonal are only blue and the remaining are red. we are supposed to find the number of red tiles used. Another important information here given is the number of blue tiles is 121. That is the number of tiles which have been arranged around the diagonals, along the diagonal, the two diagonals is 121. Well, our first necessity is to estimate the number of tiles along one side of the wall. Let me assume, as it is a square wall, I like to assume it is with the dimensions n into n. What I mean to say is, let there be n tiles along one side and n tiles along another side. The number of tiles, by n I like to mean the number of tiles. So the total number of tiles is n into n, that is n square. Okay, now here two cases will arise. N might be even or n might be odd. What happens? Let us see the two cases. If n is even, then what is the number of tiles in this diagonal? N. Again in this diagonal, n. The total number of tiles in both the diagonals is n plus n, implies the number of diagonal tiles is equal to n plus n. I mean to say diagonal tiles is those tiles which have been arranged along a diagonal. Along the two diagonals, n plus n tiles will be there, but n plus n is equal to 2n is even. But this is not the case. Why is it not possible? The total number of diagonal tiles used is 121. That is the number of blue diagonals, nothing but the number of tiles used along the diagonal is 121, which is an odd number, not even. Therefore, n is not even. Then n must be odd. N is odd. In this case, what happens? The number of diagonal tiles is equal to n plus n minus 1. Why should you put minus 1 there? If n is odd, then the exact middle tile will be counted twice. Therefore, in such a case, the number of tiles will be n plus n minus 1, that is equal to 2n minus 1. Surely an odd number. No doubt it is an odd number. Is odd. Therefore, this is nothing but number of diagonal tiles. That is nothing but number of blue tiles. What is the blue tiles? The number of blue tiles according to the data? It is 121. Therefore, 2n minus 1 is equal to 121. That is, 2n is equal to 122, or n is equal to 61. N is equal to 61. We could have got the total number of tiles also. What is the total number of tiles? 61 into 61, as it is n into n. Therefore, at last, let us now calculate the number of red tiles. What do you get? How do you get the number of red tiles? The total number of tiles minus number of blue tiles, isn't it? Yes, of course. Therefore, number of red tiles is equal to total number of tiles minus number of blue tiles. Total number of tiles minus number of blue tiles. What is the total number of tiles? It is 61 into 61. What is the number of blue tiles? He has given it to be some 121. 61 into 61 is nothing but 61 square, which is of course 3721 minus 121. 3721 minus 121 comes around 3600 is of course the answer. Is it available among the options? Of course, surely available. It is available among the options in option C. So the right option is option C, and the right answer is 3600. That is the question. The next question, that is the 56th question, is before us. Concentric circles of radii 1, 2, 3, 4, etc. 100 centimeters are drawn. The interior of the smallest circle is colored red, and the angular regions are colored alternately blue and red, so that no two adjacent regions are of the same color. Then the total area of the blue region in square centimeters is, that is required. What is the matter? Concentric circles of radii 1, 2, 3, etc. 100. Let me try to demonstrate the actual picture. I shall try. I have drawn only 4 circles. Radius of this is 1, radius of this is 2, this is 3, this is 4. The interior part is painted red, isn't it? The interior of the smallest circle. What is the smallest circle? The first circle, that is the circle bearing the radius 1 unit, is colored red, and the angular regions are colored alternately blue and red. What does it mean? This is red, so this is blue, this is red, so this is blue, like that. They have been colored so that no two adjacent regions are of the same color. Then the total area of the blue region in square centimeters is, okay, this is, let me call this radius R1, radius R2, radius R3, radius R4, like that. What is the area of this blue region? Pi R2 square minus pi R1 square. What is the radius of this region? Pi R4 square minus pi R3 square, isn't it? Like that. You are supposed to have the area of the blue region only. It is required. It is required. How to get it? Options given are 1000 pi square units, 50, 50, that is 5050 pi square units, and 4950 pi square units, and the fourth option is none. Let us see. I am mentioning the radii R1, R2, R3, R4, etc., etc., etc. Of course, R1 is 1, R2 is 2, R3 is 3, like that. First of all, what is the area of this blue region? Pi into R2 square minus R1 square. What is the area of this region? R4 square minus R3 square. What will be the area of the next region? R6 square minus R5 square, and so on, etc., 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 etc. What will be the last one? R100 whole square minus R99 whole square. I'm sorry, R100 square minus R99 square. This is the required area. As he asked us to have the area of the blue region only. Yes. What is that? This is equal to pi into. This can be taken as R2 minus R1 into R2 plus R1. This can be taken as R4 minus R3 into R4 plus R3. And the next one can be taken as R6 minus R5 into R6 plus R5 and so on, etc. plus R100 minus R99 into R100 plus R99. After arriving this step, we are lucky to have one beautiful concept here. The radii are 1, 2, 3 and so on. So what is R2 minus R1? 2 minus 1 is 1. R4 minus R3? 4 minus 3, 1. R6 minus R5? 6 minus 5, 1. R100 minus R99? 100 minus 99. So it is 1. So this is 1, this is 1, this is 1 and this is 1. They can be ignored. Why? Because 1 into R2 plus R1 is nothing but R2 plus R1. Like that, you can use the same concept here. Hence, this is therefore equal to pi into R1 plus R2 plus R3 plus R4 plus R5 plus R6 plus R99 plus R100, that is R1 plus R2 plus R3 plus etc. etc. up to R100. Let us now recall what is R1? 1. What is R2? 2. What is R3? 3 etc. etc. What is R100? 100. Hence it is pi into 1 plus 2 plus 3 plus etc. etc. up to 100. And it is an easy matter, of course, to estimate that using the formula n into n plus 1 by 2, as it is just the sum of 100 successive natural numbers. It can be estimated as pi into 100 into 100 plus 1 by 2. But 100 by 2 is 50. 50 into 101 is 5050. Pi. So many square units. So what is the right option? Option B is the right option and the right answer is 5050 pi square units. Option B is of course the right option. This is the time for us to go through the next question, that is question number 57. In this question, if three positive real numbers A, B, C are in AP, A, B, C are positive reals, they are in AP, such that the product ABC is 4, then the minimum value, the minimum possible value of B is, he is asking us the minimum value of B is, what is that? Let us have an observation. What are the three numbers? A, B, C are in AP, such that ABC is equal to 4, then the minimum value is. One more thing, these three are positive real numbers, hence the difference must also be positive. Without class and generality, we can assume that the difference is also positive. Yes. Let A is equal to B minus D, B is equal to B itself, C is equal to B plus D. Why should I take like that? As he has given that all A, B, C are in AP, they can take this form B minus D, B, B plus D, where D is of course the common difference in that AP. And in the beginning itself we have supposed that it is positive. Okay, then the minimum value, possible value of B is we want. Okay, here what is D? What is D? It is the common difference. What is D? It is the common difference in the AP. Well, one more condition it has been given. There has been given. What is the condition? ABC is equal to 4. He has given that ABC is equal to 4. But ABC is equal to 4. What is A? We have, according to our assumption, B minus D into B. What is C? B plus D is equal to 4. Is equal to 4. What is it? B into B minus D into B plus D is B square minus D square is equal to 4. What is B into B square? B cube minus BD square is equal to 4. Isn't it? B cube minus BD square is 4. From that we can say that B cube is equal to 4 plus BD square. BD square. Well, let me recall this step once again. What is B cube? B cube is equal to 4 plus BD square. Now you please observe this step. What is B? Positive from data. What is D square? Positive, of course. Irrespective of the nature of D, whether D is positive or negative, we do not bother about it. D square is surely positive. This is positive. This is positive. Therefore, this is greater than or equal to 4. This is greater than or equal to 4. So, the value of B cube is always greater than or equal to 4. It can never be less than 4. So, minimum value of B cube is 4. That is, B cube is greater than or equal to 2 square. From which you can write that B is greater than or equal to 2 power 2 by 3. That is, B can never be less than 2 power 2 by 3. That is, the minimum value of B is 2 power 2 by 3. It is available, of course, in option B. That is the second option. Question before us is question number 58. In this question, he is asking us the last digit in the expansion of 2007 whole to the power of 2010. 2010. He is asking like this. Okay, how to estimate the last digit of a particular number? You see, what is the digit in the units place? 7. Let us observe the exponents of 7. What is going to happen? 7 power 1 means 7. If 7 square is observed, what is 7 square? What is 7 square? 49. In that 49, what is the last digit? 9. 7 cube. What is 7 cube? 343. What is the last digit? 3. 7 power 4. What is 7 power 4? 2401. What is the last digit? It is 1. Actually speaking, you need not be knowing 7 power 4, 7 cube, etc. 7 power 1 is 7. 7 square means into 7, 49. Last digit is 9. 7 cube means into 7. 9 sevens are 63. Last digit is 3. What is 7 power 4? Into 7. 3 sevens are 21. Last digit is 1. What is 7 power 5? What is 7 power 5? Into 7. 1 into 7 is 7. So it is 7. What is 7 power 6? Into 7. 49. It is 9. What is 7 power? What is the last digit in 7 power 7? Previously we have had 9. Into 7 is 63. Last digit is 3. What is 7 power 8? Already you could have had 3. Into 7 is 21. The last digit is again 1. You can proceed like this. You can proceed like this. Okay, look here. If 1 is there in the exponent, last digit is 7. If 2 is there in the exponent, it is 9. If 3 is there, it is 3. If 4 is there, it is 1. But here, 5. If the exponent is 5, you think of it in this way. Divide 5 with 4. What is the remainder? 1. If the remainder is 1, last digit is 7. Divide it with 4, remainder is 2. If the remainder is 2, last digit is 9. 7 power 7. Divide 7 with 4, the remainder is 3. If the remainder is 3, last digit is 3. Here, what is the remainder? If you divide it with 4, it is 0. If it is 0, then the last digit is 1. The question is, why is it necessary to divide the exponent with 4 only? Why? Because the last digits are being repeated for every 4 successive powers. You observe 7931, 7931. Next 4, yes, 7931. 4 successive powers, if you observe 7931, 7931, 7931. Periodically with 4 times, that is with period 4 you say, even if you want to have in the language of functions, yes. By observing all these, 2010 is there. Now divide it with 4. What is going to happen? What is the remainder, you tell me? 2010 divided with 4. 5 4s are 20. 0 1 0. 2 4s are 8. 2 4s are 8. So remainder is 2. If the remainder is 2, what is the last digit? 9. Therefore, the last digit is 9. Last digit is 9. Last digit is 9. That is, answer is the 9, and the right option is B. Option B is the right option. So you may have to observe these things to have the actual last digit. One more question you may raise. That explanation is given in terms of sevens and the number given is 2007. How can it be valid for this? We are interested to find the last digit, that is the units digit only. And it can be applied to the digit in the units place, that is 7. It's enough. Similar type of discussion can also be made here also. That is why the answer 9 is correct. That is the option B. Second option is the right option. That is option B is the right option. Let us look at the next question. That is question number 59. In this question, on a plane there are 37 straight lines, of which 13 pass through the point A, 11 pass through the point B. No 3 of the lines pass through one point. No lines pass through both the points A and B, and no 2 are parallel. So many restrictions have been given. Then the number of intersection points of the lines is, that is the number of points of intersection of the lines is. Okay, one important and useful information has been given. What is that? No 2 of them are parallel. We are lucky. What is the total number of lines? 37. With no 2 of them are parallel. To have a point of intersection, how many lines you have to select? 2 lines. If 2 lines do intersect, you will be going to have one point of intersection. So to get a point of intersection, you are supposed to have 2 lines. That is, you are supposed to select 2 lines. What is the total number of lines given? 37. Out of 37 lines, how can you choose 2 lines? 37, 2, C2. So, the total number of lines is 13C2. One more thing. This is not the right answer. There are so many restrictions. There are 2 fixed points, A and B. Passing through A, there are how many lines? Some 13 lines pass through A. And there is another fixed point, say B. Through B, how many points are there? How many lines are there? 11 pass through this point B. Actually speaking, if 13 lines are there, we generally count that the number of points of intersection to be 13C2, which is not the case, because all these lines pass through one point only. Just like that, all those lines pass through one point only. Therefore, the required number of points of intersection can be 37C2. Are these valid or invalid? Invalid. So, minus 13C2. Again, are these valid or invalid? Not valid. So minus 11C2. One more thing here, you might have to concentrate on that. The points of intersection that can be obtained by these 13 lines is not 13C2, but 1. Why should you take it as 1? You have to include A among the points of intersection. Just like that B must also be included. Therefore, the actual answer needed is 13C2, 37C2 minus 13C2 minus 11C2 plus 2. If you can calculate this, that comes around 535. What is that? 535. It is an easy matter to calculate this. You can do that, and the answer is 535. That is the option B. Second option is the right option, and the right answer is 535. The next question before us is the question number 60. In this question, there are 4 persons who like to develop some items. Altogether, those 4 persons A, B, C and D develop 18 items. Out of them, 5 items jointly by A and C, 4 items jointly by A and D, 4 items jointly by B and C, 5 items jointly by B and D. The number of ways of selecting 8 items out of 18 so that the selected ones belong equally among A, B, C and D is a beautiful question. It is a beautiful question. Let us try to represent, rather demonstrate the data in the form of a tabular form. Let us demonstrate the data in the form of a tabular form. You can express like this. By looking at the tabular form itself, you will be able to say that both A and C jointly develop 5 items, both B and C jointly develop 4 items, like that. This is exactly according to the data. The number of ways of selecting 8 items out of 18, so that selected ones belong equally to A, B, C and D. Okay, this can be observed in so many cases. This can be observed in so many cases. What are the cases? Suppose I select 0 items here, I select 4 items here. What happens? 5C0 into 4C4. It can be done here also, so whole square, plus 5C1 into 4C3 whole square, plus 5C2 into 4C2 whole square, plus 5C3 into 4C1 whole square, plus 5C4 into 4C0 whole square, 4C4 whole square. 5C4 whole square into 4C4 whole square. Isn't it? Here we have select 4 whole square. 1 plus 3, 4. 2 plus 2, 4. 3 plus 1, 4. It is 4C0. Now you add all these things. You will be having the total to be 5626 is the right answer. What is the right answer? 5626 you will be going to get. So this is the right option and the right answer. Therefore the answer is option B. That is second option. Answer is 5626.